Everyone, you are all welcome to this video of general heat conduction equation in cylindrical coordinate. First of all, we just take an element. This is called differential volume element in cylindrical coordinate. Means we have a cylinder and we just take one element of that cylinder and we put it here. So this is the element. Now we just made the naming, like we just take it r dr. This is a small element, so dr. Now this is also have a three direction. One is z direction, r direction and phi direction, and we just name it as angle d phi. So the heat conduction will be goes from all three direction, means r direction, phi direction, and here d phi or d phi direction. Okay. Now here some of the important terms of this. Important terms are Q, heat flow in that direction, rho is the density, C is the heat capacity, K is the thermal conductivity, and Qg is the heat generation per unit volume. Here the volume of the small element dV is r d phi, dr and dz. This is all the volume of this element. Now you all know that from energy balance, the total net heat accumulated in the element due to conduction, we denoted it by A, plus heat generated within the element, we denoted it by B, is equals to energy stored in the element, which simply here is the case of heat conduction. So the energy will be thermal energy, which is equals to Q is equals to mc delta T. So from these equation we have an energy balance equation here. Now all you know about the Fourier law. Fourier law states that Q is equals to minus Ka dt by dx. This is the temperature, and you know that heat flow from higher temperature to lower temperature. So here will be a positive negative sign. So the difference will come out to be negative, and both negative comes out to be positive. Okay, so we put it here negative sign. Now first of all we calculate about A. Now for A, heat flow in phi direction means this direction. Now you all see that heat in means heat in this direction will be Q in minus Ka delta T by r d phi. Here we take the element, means this element that we take here. So here we come out to be r d phi. Now heat out is equals to Q phi plus d phi. Okay, Q phi plus V. So the heat retained in the element means heat stored in the element will be the subtraction of this Q phi plus d phi minus Q phi, and here it come out to be minus dq phi upon d phi dot d phi. Okay, means it come out to be this, and we just make it differential, so it come out. Now what is from Fourier law? It come out to Ka delta T by delta T, and by differentiating it come out to be. Now here you take the area is r d phi and dr. See, you are taking this direction, so the perpendicular area of this is r d phi and dz. Okay, now if you are taking this direction, then we take this perpendicular area, means this. So heat will be accumulated in this direction, and we are taking this area. Simply it goes out and we are taking this. When it come out to be here, we are taking this area. So it come out to be. Now this is the equation first. Now in r direction, heat in Q r is equals to minus K dt by dr. Means in this direction it come out to be dt by d. Heat out is equals to Qr plus dr. So heat stored will be the subtraction of this, and this come out to be this. So delta dq r upon dr, we make it in differential form. From Fourier law it come out to be d by dr Ka dt by dr dot dr. That d by dr we make it in inside. So Ka come out to be constant, and d square dt upon dr square dot dr. Now here the area will be r d phi dot dz, because it is also perpendicular area. Here we are in r direction, so the perpendicular area will be r d phi dot dz. So here the equation will come out to be this, and we put it second. Simply similar in z direction, heat stored is equals to qz. Here the area is q r d phi dot dr, and this come out to be differential form, so it come out. All by adding 1 2 3 we come out to be this is the common, and the equation remaining are this. Now heat generation, we just simply say that heat generation per unit volume. So Q generation is equals to Q generation into volume, Q generation into r d phi dot dr dot dz, and the thermal energy stored Q is equals to mc dt by dt. It is per unit time. So the mass will become out to be rho into volume into C, and volume elemental. So it. Now putting all these equation A, B, C, and adding A and B and putting in energy balance form, we come out to be this. This term will be cancelling out from both the LHS and RHS direction, and we come out to be a net heat accumulated equation, which is this 1 upon r square d square T upon d phi square plus d square T upon dr square plus d square T upon dz square plus Q generation is equals to rho C K dt by dt. And here rho C by K is equals to 1 upon alpha. Alpha is equals to thermal diffusivity. Hope you all like this video. And if you all like this video, then please subscribe to our channel Tech Bros, and I will share this type of video here. Thank you everyone.